So today we're going to be looking at cotangent waves. Now, cotangent waves, similar to the cosecant and secant waves, are going to be another type of reciprocal trig identity. And cotangent are going to be related to, you guessed it, the tangent wave. The process is going to be very similar to how we graphed secant and cosecant. We're going to use the tangent function in order to graph the cotangent function. Again, if you need to plug in a cotangent into your calculator, most calculators don't have a cotangent button. You're going to have to figure out what the value of tangent is with those values and just go ahead and take 1 divided by that. But let's hop into the cotangent function. So now with cotangent, we realized that with tangent, there really wasn't a whole lot going on as far as amplitude. Mostly what we needed to figure out was how often does this thing repeat itself. Now, with cotangent, let's go ahead and pair this up with tangent. Tangent repeats itself every pi units, so is cotangent. So I'm going to take pi over b. In this case, my b is 1, so it's just going to be pi. Now, with the tangent, let's go ahead and see what that would look like on our graph. I know every pi units, my tangent function went ahead and did this little thing where it had an asymptote right here. Every, half a pi unit, and it would curve up as it went towards them. We're going to see how we can use this to just graph our cotangent function. Okay, so now looking at this relationship, tangent and cotangent. Let's see. Tangent is going to be opposite over adjacent, which in the case of a unit circle, we know this is y, this is x, and this is r. If I'm looking at opposite over adjacent of my initial angle, opposite is y over x, which means my cotangent is going to be x over y. So again, I'm going to have lots of asymptotes because y is going to hit 0 quite often. When does y hit 0? Well, y hits 0 exactly in between where x hit 0 previously. So we're going to do a little bit of swapping. At the value where my tangent was undefinable, that meant that my y value was 1 and my x value was 0. If I flip that, I have 0 over 1. So I know that at each asymptote, I have a value of 0 for my cotangent function. So I'm going to go ahead and pop in all those values. And likewise, with my tangent function, when my y over my x was 0 over 1, so 0 over 1, if I flip that for my cotangent, I'm going to have 1 over 0, which is going to be undefined. So I've almost swapped my zeros and my asymptotes on my cotangent function. So I get something that looks like that. The next thing that I'm going to do is figure out, okay, if my graph goes here and hits an asymptote here, is it going to look the same and they're going to curve up, or is it going to curve down? And so we're going to have to explore what the relationship is as it approaches this asymptote. Now, with tangent, let's take a look at that first iteration because that's the easiest to visualize on the unit circle. Yeah, I'll scoot it over a little further. Okay. So with the tangent, between 0 and 90 degrees, actually between 0 and pi, where we know the tangent function repeats itself. The tangent was 0 over 1 and 0 over negative 1. We know in between those values, boop, boop, we go up and we start going up again as we approach into the negative. But let's take a look between here and here at the cotangent, and let's flip these values around. So if I know it's opposite over adjacent, that's going to be y over x. These, they're going to be equal. So 1 over 1, my tangent function was equal to 1. Now if I flip that 1 over 1, my cotangent function is also going to be equal to 1. They, in essence, touch right at this 1, 1. And that's going to repeat every time we see that upward motion. They touch right there. Let's look at the other side as we come around to the downward direction. So with my tangent function, this is going to be right between, let's see, that point and that point right here. So my y divided by my x in this case is 1 over -1, which is going to simplify down to a -1. Now if I flip that, my cotangent function is going to have the same value. So I know I'm going to have an equal point right there on every single one of my cotangent functions. And from this, that's all I need to do to graph my cotangent relationship. I know I'm going to have a point right here. It's going to curve down through that and come towards that asymptote, towards that asymptote. And so what we see is that the graphs share a certain type of relationship. The asymptotes and the zeros are flipped. We also know that they have some shared values, just like the other reciprocal functions we had at the maxes and mins. But at these maxes and mins, these are just at the local 1-1s. As the tangent function goes up, so does the cotangent function. They're both in a positive direction, and when one's negative, so is the other one. Because if I flip a negative number, it's still a negative number, but the absolute quantity of those changes. So this was, let's see, with my tangent, a big number over a little number, flipped it's a little number over a big number. So infinity became 0, but their approach on either side is still positive, still negative, still positive, still negative. That is going to be a base cotangent function. So we're going to graph our tangent function, we're going to swap our zeros for our asymptotes, and then cause our cotangent to go in the same direction that our tangent was. So let's use that information to graph number 3. Now number 3, we know this is paired up with our tangent. What I've got going on here is my period is going to be pi over b. In this case, my b is going to be 1 over pi. So pi over 1 over pi, which is going to be pi squared. My period is a very big period. So let's see. What normally would be right here, there's no shifts, so I know that my function is going to be the same. Pi squared is roughly 9 point something. 9 point something, which if this is right there, that means right here would be an asymptote. Foop. Foop. Okay, perfect. So that would be my tangent function. Instead of that. Now what I'm going to do with my cotangent function is at the asymptote, I'm going to put a 0, and at the 0, I'm going to put an asymptote. The next thing I know is that my cotangent, if tangent was positive right here, cotangent's also going to be positive. If tangent was negative, cotangent's also going to be negative. So we're going to see the fact that the graph's negative, also going to be negative. The graphs are going to be related just like the other ones, which is going to bring us to our last few. Okay, we have this one. This tangent function, so it's related to tangent. I know it's been shifted to the right by pi units. I also know the amplitude has been stretched by 3, so that's a 3 times stretch, which means that it doesn't really affect too much of our graph. It affects how quickly it goes up and down. So let's go ahead and graph our really quick tangent function and see what that would look like. Okay, so I have what was my 0 is now going to be shifted over to the right by pi units, which is the period, so perfect. I know that in between those is going to be an asymptote. I know that this is going to be a very vertical because of that stretch. Boom. I have my tangent. Something stretched more like this. This is probably not stretched far enough, but it's going to give us exactly what we need to graph this. I'm going to swap my zeros and my asymptotes, because I know with cotangent, something over infinity, if I take infinity over something, is going to be a very small number. And likewise, if I take 0 divided by something, if I take something divided by 0, I have asymptotes right here. And then at that point, that's all we need. I know I'm going to curve up with my tangent and down with my tangent. Actually, I should draw them a little steeper. I'm going to stretch these guys out just a little bit, because we can't forget about that 3. So stretch them up a little steeper, down a little steeper, down a little steeper, and then up a little steeper. Boom. And we have ourselves a nice little cotangent. So now that you've seen that, what I want you to do is I want you to look at number 7, pause the video, try it out, see how well you do, unpause it when you're done, and check your work. Okay, so let's take a look at how we did. So this is paired up with a tangent function. With the tangent function, I'm going to pull out this pi, which will leave me with an x minus 2 plus 1. Okay. So if tangent normally has a period of pi over b, pi over pi is going to give me a period of 1. So we're going to have a lot of drawing going on here. The other thing is I have a right shift by 2 units, and I have an upward shift by 1 unit. So be prepared. This graph is going to be a very tightly drawn graph. Again, mainly because we shrunk that period. So let's go ahead and draw some tick marks. If I have a period of 1 and I have whole number shifts, I need to go ahead and relabel my axis. So that'll be roughly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, roughly there. Not the best, but it'll do. Okay. So normally it's here would be my 0. Instead, I'm moving it to the right 2, boop, boop, and up 1. So because my midline is right here, I'm going to go ahead and draw my midline. This is going to tell me where I swap zeros and asymptotes. I know every one of these things, there's going to be a 0. And between them, I'm going to have an asymptote. So what I'm going to do is I don't really need to draw too much of those. I know I'm going to swap my asymptotes. So in between each one of my previous points, this was an asymptote. Go ahead and draw a point. I think that was it. And then between that and over here. I also know that every one of these blue tick marks was a 0 on the tangent function, so it's not going to be a 0 on my cotangent. It's going to be an asymptote. Talk about confusing to draw. Okay, and so now let's take a quick look at how my tangent would have gone. It would have gone from its 0 to my asymptote up and down. So that's all I'm going to draw of my tangent. That'll give me just enough to graph my cotangent. My cotangent goes up with tangent, and it goes down with tangent. So that's all I need. Whoop. There we go. And so that is graphing a cotangent function using its parent or its original trig identity, which was a tangent wave. And that is a messy, but not too bad to do. There you go.